On this video, we're gonna go through the process of integration. Okay. So we need to know that the process of integration reverses the process of differentiation. Right. First, in differentiation, what we do is we start with a function. Let's say this is the function. The function is 6x squared. Okay. In differentiation, what we do is we take that one day. So 6x squared. We take this one here. We bring it here. Alright? And then we minus the. So what we're finding there is fx prime. Okay? Fx prime, which gives me 12x. This is what we do in differentiation, right? And again, if the prime function, okay, the primary function was 2x plus 3. If you want to find the differentiation of this one here, in differentiation, the differentiation of a constant factor is 0. So applying the formula as I said, so I come here, I say x, there is a 1 there, so that's 1 there, minus 1 as done there, and that's 1 there is here. Okay? So as I said, the 2 went there, so that's 1 came here, and then a minus 1 there, and that's a constant factor is 0, which then gives me differentiation of 2x plus 3 is equal to 2. Right? Okay. So now in integration, what you want to find? We want to find what this was, okay, before being differentiated. Right? That's simple, I think. So now let's say that we have to find the function. Let's say our fx prime is 3x dx. Okay. So what integration does is to find what fx was. Right. So now if I want to find that, that's what I call integration. So I come here, I say fx is equal to the sign of integration, integral of 3x dx, right? This one will be given by. Now I want to reverse what happened here. So I come here, I say 3x, right? So now there I was minusing. Yeah, I know there is a 1 there. So there is a 1 there. Instead of minusing, I say plus 1, I add 1, and what I have there, I bring it down here. Okay? What I have there, I bring it down there. Right? Then, since I don't know if there was a coefficient, and I assume there was a coefficient, I say plus, okay, a constant factor. I was talking about a constant. I believe there was a constant factor, plus a constant factor, which could be 1000, 1000, which could be 5, whatever it was, but I put it there. So then those will give me 3x, right? Exponent 2 over 2 plus c. Okay? This is what integration does. So this is the first step. Okay? This is the first step. So I'm gonna take one as a size, okay? And I'm gonna do integration on that one. Then we're gonna carry on. Let's say I'm given this function. Okay? I'm given this function. Here is my function, and this function has been differentiated, which is 5x squared plus 4x thus plus 2, okay, everything here dx. Now they want me to find the function of x. Then what I do is I come here, I say this one here, if you guys want me to find this one, I'm gonna need to integrate this part, this equation. Okay, so I'm gonna say this f of x, okay, is equal to integration of 5x squared plus 4x plus 2. Alright, and this one here will be the same as saying f of x is equal to integral of 5x squared dx plus integral of 4x d squared, dx plus integral of 2 dx. So that is the same as saying that. So now I'll come there and say 5x, okay, I put a 2 there, I say plus 1, whatever I have there I bring it down there, 2 plus 1 and plus, that's one of the 4x, knowing that I have a 1 somewhere there, so I say x1 plus 1, what I have there I bring it down here, right, and I carry on, I go there, I say plus 2, okay, plus 2. Since, remember what I showed you in derivation, in differentiation, you can see 2 is the same as that one there, that's the same thing. So here and then I'm saying 2x to x0, that's where it was, this was x0, okay, so x0 plus 1, so I'm gonna have the 1 there, which then will change nothing there, right? And I have to assume that there was a constant factor, and that will be plus c, okay. So I'm gonna say my function now is 5x cubed over 3 plus 2x squared plus 2x plus c, okay. Right, so let's get on with our process. We don't always find equation in this form, okay? Sometimes we need to simplify before you integrate the equation. So the integrand might be of this shape. Let's say we have square root of x, okay? I open my bracket, 1 plus x squared at power 2 d of x. Let's say that you have to integrate this one. So how do you do it? It looks simple, but first you need to expand it. It might look simple to some people, but to some other people it might look difficult. So how do you do it? You expand this part here. If you don't want to confuse yourself, you expand this part there. So you come here, you say 1 plus x squared, okay, at power 2. This one gives me 1 plus 2x squared plus x exponent 4, right? So you take this one here, you take it back there, you bring it back there, okay? So you take it, you bring it back there. So now you come here, you say that one is then equal to square root of x, open my bracket, 1 plus 2x squared plus x exponent 4 d of x, or dx, right? Now you see that part there, you know what that is, right? So square root of x is equal to x exponent 1 over 2 or half, right? So which will bring me to this shape here. I'm gonna have integral of x exponent 1 over 2 open my brackets plus x2 s squared plus x4 dx, right? Which gives me here, I'm gonna have x exponent of plus, there I'm having 2x exponent 5 over 2, right? Plus that one comes there, and then it's gonna be 4.5. So x exponent 9 over 2, that gives me 4.5, and this one in bracket d of x. Okay, this brings me then the general solution of the integral, the one that I showed earlier. So a, okay, times x exponent n g of x is equal now to a times x exponent n plus 1 now over n plus 1 plus a constant factor, right? So now that's how we have here integral of x exponent d exponent 1 over 2 dx plus integral of 2x exponent 5 over 2 plus d of x d plus, okay, integral of x exponent n over 2 9 over 2 dx, and this is as easy as it can come. So we have the 3 over 2 divided by 3. Now that one will come there, I have 2 there, I have 3 here, so that is equal sign, eh? Don't get confused there. So here I'm gonna have 2 first, x, then that one there will be 1 7, okay, so 7 over 2 over 7 2 there, okay, because that's one there is plus 1 2 7 2 here. Then again, and here I'm gonna have x 9 plus 1, which here will come here 9 plus 2, because that's 1 times that, and then I'm having 2 plus c. Okay, so this is an easy thing that you can do. So it becomes 2/3 x plus 4x 7 day plus, okay, 2 over 11 x exponent 11 over 2 plus a constant factor, right? So this is how you get solution to this kind of problem. So I'm gonna write for you some exercises so that you might, get deep into this, and then after that we're gonna take another step further, right? So these exercises are for you, okay? Let's say that you have the integral of 2x exponent 3, okay, plus 2 x exponent 2 minus 8x plus 4 over x6, okay, d of x, okay. So that's one day, and then we have another one. That's your first one, that's your second one. So you can, you can go through this one here and see if you understand, okay. And here I go again. x5 plus 2x plus 1, okay, d of x, and third one, the third exercise will be x 3d. I have x4 plus 5 x2 plus 1 d of x. So I want you guys to find for me, for this exercise, what fx what fx is for each of them. Alright, so go through it and find for me the answers, and then after that we're gonna go another step further. So now let's talk about integral by the method of substitution, right? By substitution. So this integral is the one in the shape of, let's say, 3x plus 10, okay, exponent 7, or 4x exponent 5 plus 1 exponent 6 times x4, okay, and so and so. So this kind of integral, okay, so you need to use the method of substitution, right? Great. So let's start with this one, okay, let's start with that one. Looks easier, right? Cool. So let's say that we need to find the integral of 3x plus 10 exponent 7 d of x. So what I do in this case, okay, I check here. So in here, seeing that if I had to do the differentiation of this part here, okay, I'm not gonna have any x left in the equation, right? So I'm gonna say, and then let me say t is equal to 3x plus 10. So if I had to do the differentiation of d of t, I'll get 3 d dx. Agree with me, right? Then dx will be equal, or it will equal dt over 3. Then I take this one here, I substitute in my main equation. Then I will say this integral will be equal to t exponent 7, right? T exponent 7, and dx is equal to dt over 3. Then I'll say dt over 3, right? This is a coefficient factor. That is a coefficient factor 1/3 t exponent 7 dt. Okay. Then I'll say I take the coefficient factor, I get out of the sign of integration, I put it there, 1/3 t7 dt. Okay, this one brings me back to what we showed earlier on. Then I'm gonna have 1/3 t7, remember, plus 1 now, come on, plus 1 now, okay, over 7 plus 1, great, and plus c. Fine. Then I'll go further by saying 1/3 t8 over 8, 124 t8. Now I remember t is equal to 3x plus 10. Is it not? Then this will become the integral of 3x plus 10, okay, exponent 7 dx is equal to what is the 1/24. I open my bracket, I say 3x plus 10 exponent 8 plus c, okay, plus c, right? So this is the answer. I repeat again, when you have the integral of that kind, okay, so you need to pause, you need to say t, you need to equal that one, you substitute by t or by anything else, and then you go ahead with the integration. It's like 4x squared plus 8, okay, and then there I'm having x2 dx, the integration of that one there. So you need to say this one here, you need to consider that one being equal to t to d, whatever you want to do, but make sure that does not confuse you, right? I'm gonna leave for you guys some exercises, okay? Then you guys gonna pause it, gonna pause the video, you're gonna take the solution of the exercises, then us, we're gonna take another step further. So saying that we have this one, okay? It's a 3 there, and that times d of x, okay? So as I said, by the method of substitution, I'm taking this example before. So what you're gonna do here, you start by saying t is equal to 4x4 plus 6, right? Then you come here, you say d of t then will be equal to let me make it clear for you now, it's fine. So d of t now will be equal to 4 over 4x exponent 3, right? So that is d of t dx, which then will say then d of x is equal then to d of t, that one, those two go away, 4 and 4, 4 over 4 over x exponent 3, right? So once I have this one, once I have this one there, then I'll come there in my equation, I'll substitute this one there in the main equation. Then I'll have, okay, t exponent 3 t cubed, and then x cubed d of x, which is here d of x is equal to dt over x3. That and that go away. I'll have t cubed dt, right? And this one here, the integral, remember, I'll have then t, okay, 3 plus 1 over 3 plus 1, remember, plus c. This one is t exponent 4 over 4 plus c, which then will be equal to, say, the integration of 4x exponent 4 plus 6, everything cubed, x cubed dx is equal to, I take that one, I bring it back there, is equal to, I open the bracket, 4x4 plus 6 exponent 4 over 4 and plus a coefficient factor, okay, right? Then in short, what I would say then here in short, okay, so if you have this case here, integral of this form, the general solution of integral of this form, u exponent u, okay, d of u, okay, this one will be equal to u n plus 1 over n plus 1 plus c, right? some examples to help you identify if you need to use this method, get this method of integration, get for integral by parts. I'm gonna take one example. This is the example that I'm gonna take for you. Then we're gonna integrate this together, right? And then I'm gonna leave for you some exercises, right? So as you've seen how we can do integral by parts, what you do is you say u ddv is equal to uv minus integral of v d of u, right? So now in this case, you need to find out which one is your d of v. In this particular example, when you see e exponent something, identify that as d of v, right? So let's now proceed. I'm gonna show you how you can do this. Okay, so you start now by saying, considering that d of v is equal to e exponent x d of x. So now for you to find v, you need to integrate this part, and the integration of u of ex dx is, so if I have to integrate ex dx, I'm getting ex, right? So I take this part here, I bring it in my solution. So look how it's gonna be. So the integral of that one will be equal to u. What is u? U is x plus 1. So u x plus 1. What is v? Here is v. dv. There is v. Okay, you can see there. V is equal to e exponent x. And then e exponent x minus v, which is e exponent x. Now u is equal to x plus 1, which means d of u now is equal to, we know that if you have to do the derivation of x plus 1, you're getting 1, right? So here I'm gonna say 1 dx, 1 dx. Okay, then I'm getting x plus 1 multiplied by ex minus now ex, because the integration of ex dx is equal to ex, we saw it today, thus plus c, a constant factor, right? So this is how you do when you have this kind of integral. So this is one of the exercises that students are tricks with when it comes to integral. So this is how you solve this kind of things. Okay, I'm gonna first expand that one. So it's gonna be sin of x, okay, times sin of x d of x. We all know this property of integral, which says, okay, integral of u ddv is equal to u v minus v ddu. Okay, so now our integral will be equal to, okay, integral is equal to u, which is our sin x, okay, sin x, and our v now, ddv is sin x dx, and the integral of sin x dx is minus cos x. Okay, so we get that part there, then we need to carry on. So minus v now, which is this part, minus cosinus x ddu, and remember u was sin x at first, so d of sin x is cos x d of x. Okay, so we have that part now. So now we carry on this way. So that part there is now equal to minus sine of x cos x, that one, plus, okay, plus that multiplied by that cos x squared d of x. Okay, we know this trig property which states that 1 is equal to sin x squared plus cos squared of x. Okay, so that's what we're gonna use there, which will imply that our integral, okay, is equal to minus sin x times cos x, okay, plus integral of 1, okay, 1 minus sin x minus sin x d of x. Okay, so we have that part over there. Okay, so we'll carry on this way now. So now this integral give you name. Okay, so minus sin of x times cos x plus, okay, plus that one comes there, d of x minus sin of x squared d of x. Okay, I have integral there. Right, so this one comes this way, so I'm having the minus sin of x cos x, okay, plus integral of d of x give me x minus integral over sin x squared d of x. So remember that our question was we must find the integral over sin x squared d of x, which is the same as that one, right? So which gives me then the power to say that, okay, 2, because this one comes this other side of, this other side of the equal. So this gives me then 2 integral of s sin x squared d of x, okay, is equal now to minus sin of x, right, times cos x, okay, plus x, right, this plus c, okay, right. So now this is how I do it. So since I need that one, what I'm gonna do is I'm gonna say sin x squared dx, okay, is equal to, okay, so let me change my marker. So this one is equal to 1 over 2, so half of minus sin x times cos x plus x, I close my bracket, plus c, okay, plus c. So let's take now integral of e exponent 3x times sine of 2x d of x. So when you find yourself in this kind of situation, remember you do integration by parts. Okay, I state it again. So now you need to find, okay, let me set for you. So integration of u d of u is equal to v times u minus v d of u. Right, so let's say that in our case, let's say that is our dv. So let's say our dv here is sine 2x dx. The integration of this one here, okay, the integration of dvx, the integration of that one is equal to minus 1 over 2 cos x. Okay, so that is the integration of it. Okay, so then I come here, I need to take u. So what is u? U is equal to 3x, which means d of u is equal to 3 3x dx. So now I bring it this way. So my integral is equal to vu. Where is v? V is minus 1 cos x. Where is u? U is e exponent 3x minus now v, which is the same day, 1 over 2 cos x du. Du is 3 e exponent 3x d of x. That way. So now I go further. I'm having minus 1 over 2 cos x e3x plus 3 half exponent of e3x cos x. You've seen that I've forgotten to somewhere there. Sorry for that. Cos 2x. It's fine. Cos 2x dx. Right? So once I have that one in place, I go further now. So this time I'm gonna focus on this spot. I'm gonna focus on this one because this one is almost bringing me back to that one over there. So if I focus on that one, I'm gonna use the same principle. So I come here, integration by parts again. Alright, so this time I'm considering dv being cos of 2x dx, which means then u is equal to, sorry, what did I say? dv, which means that v is equal to 1 over 2 sine of 2x dx. That one. And then I consider u being e exponent 3x, which means then d of u is equal to 3 e exponent 3x dx. So now, I'm having this one here, and I'm gonna call this one here E2. So since I've done this part here, so E2 is equal to, look this way, is equal to VU. So V is 1 over 2 sine of 2x, and U is e exponent 3x minus I have 1 over 2, I have 3. These are constant factors. Sorry, I'm gonna take them out of the sign. So I'm gonna have 3 over 2 e exponent 3x, that dx I can see it of course, times sine of 2x now d of x. Remember, this is the primary integral that we had, the one over there, the one that we had previously. So now what I'm gonna do is I'm gonna try to put this one together, in the main equation, the one that I'm seeing here, the one that you're seeing there, the one that you're seeing there. So then the integral of everything will be 1 minus 1 over 2 cos of 2x e exponent 3x plus now 3 over 2, the 1 over there, I open the bracket, 1 over 2 sine of 2x e exponent 3x minus 3 over 2. Instead of wasting my time, that's one, I'm gonna call it the primary integration. I'm gonna say e again, okay? I wanna say e again as the one that is the other side of the equal sign, e again, okay? Then I close the bracket. Then I'm gonna take this integration, this one, I'm gonna take it the other side of the bracket, which means then I'm gonna have this other side, I have 3D, which means these two are gonna give me 9 over 4, right? 9 over 4. So I'm gonna say I plus 9 over 4 I, because this one comes inside, is equal to minus half cos of 2x e exponent 3x plus 3 over 4, okay? Sine of 2x, okay? 2x e exponent 3x, right? Okay, so I'm gonna write it for you this way. So I'm having, okay, so I'm having e plus 9 over 4 I plus 9 over 4i. This one is equal to 13i over 4, okay? So which means then I is equal to 4 over 13. I open the bracket, over 13 minus 1 over 2 cos of 2x times e exponent 3x plus 3/4 sine of 2x times e exponent 3x. I close the bracket, I say plus a constant factor c, right? So if you want, you can explain it as you wish. So this one can go inside, which can give me then minus 4 over 26, okay, over 26 cos, you know, you can carry on up to you, okay, plus 12 over 52 sine of 2x e exponent 3x plus c, okay? So it was a pleasure of mine sharing this video with you. I hope that you guys enjoyed. Please, okay, just at the bottom, right here at the bottom of the video is a link said subscribe. I want you guys please to press the button which says subscribe. Press that button, and next to it is a bell, okay? So click on the bell so that you'll be notified every time we post anything on this channel. I don't want you guys to miss. I love you guys so much. So take care of yourself and see you on the next video. Bye.